Now that we've talked about the Java Future interface, let's talk about the Java FutureTask class. And we'll see that that's commonly used to implement the future interface. And a future task can be used to convey the result from a thread that's running an asynchronous computation to another thread that wants to process the result of that asynchronous computation at some point. So as we saw, Java Future is an interface, so you can't actually implement it directly. So instead, you need to implement it using a class before you can make an instance that will leverage the future interface. The Java FutureTask class is one such example that implements future, although a bit indirectly, as we'll see, and it provides a cancelable asynchronous computation capability to Java. And this has also been around since the 2004 Java 5 timeframe, so it's been around for quite a while. It's gone through several implementation variants over time as people got smarter and more clever ways to implement it. FutureTask actually has quite an interesting relationship to its super interfaces, the one of which is called runnable future. So FutureTask implements runnable future, which is an interface, and runnable future in turn implements the runnable interface, which means that the future task can be submitted to a thread or to an executor from the executor framework to be executed via its run hook method. So when you execute a future task, its run hook method will be called back in the appropriate concurrency context. Likewise, runnable future also extends the future interface. And by implementing future, a runnable future, and by transitive closure, a future task can then process the results of an asynchronous computation. And as you'll see, and as we're going to talk about, various future methods are overridden by future tasks to do the kinds of things that they need to do in order to perform the future behavior. So things like checking for the results, whether the computation is done, checking to see if the computation is canceled, canceling the computation, and so on and so forth. FutureTask provides a number of interesting capabilities in addition to what it inherits from its base interfaces. One thing you can do with FutureTask is you can use it to wrap a callable or a runnable, which are common ways to get computations executed in Java. And what's neat about this is by using FutureTask, these computations can now be run asynchronously in a background thread or background threads, depending how you do things. Something else you can do with FutureTask is you can start and cancel a computation. So typically what you do is you pass in a runnable or a callable to the FutureTask constructor, and then you pass the FutureTask object to either a Java thread or some executor, like the thread pool executor or the fork join pool executor and so on. And then the computation can run when its run hook method is called back, which is inherited from runnable. And you can also, of course, cancel that computation as well. Likewise, you can check to see if an asynchronous computation completed successfully by calling the isDone method, or you can also check to see if the computation was canceled by checking the isCanceled method. Both of these methods clearly return Booleans to say true or false whether either completion or cancellation occurred. One other thing you can do is you can get the results of an async computation. And as we saw before, there's a couple of different ways to do this. You can do this by calling get, where it blocks until the computation is done or until an error occurs. You can also call the timed version of get, which can be used either to wait for a certain amount of time to elapse, or you can also have it poll and give back a result right away if there is one, otherwise give back a null. Something else interesting that you can do is there's actually a hook method that's part of FutureTask called done. And when the future task is done and everything has finished, then the done hook method gets called back. And this is a way to be able to certain kinds of completion callbacks, like put the results into a queue of some sort. And that's actually what's done with the Java Executor Completion Service framework, which again is the subject of other classes that we may cover later. So some really cool methods that are available on Java FutureTask to make your life easier. So how can you apply a future task? Well, we're going to look through this in some detail here when we get to the case study, but I wanted to foreshadow it by describing how the ActiveObject class uses a future task to help define a closure that applies a function parameter within the context of a virtual thread object. So there's going to be a makeThread factor method that we'll take a look at inside the ActiveObject class here shortly that's passed this function and a parameter to apply the function to. It then goes ahead and makes a new future task that passes a callable as a lambda expression. And that callable is going to apply the function on the parameter n. And it's going to store that result into a field that's part of the ActiveObject class called mResult. After we've created this runnable future, we're then going to go ahead and pass that as the parameter to the thread start virtual thread method. And that's a factory method that makes a new virtual thread that will run that computation asynchronously in the background in the context of that virtual thread. And you can see how we also store the return value from start virtual thread into another field called mthread, because we're going to need that later. And then the final thing that happens here is that the runnable future that we created with the future task is going to be returned from the make thread closure method, and that will then be stored in a field by the ActiveObject constructor called mRunnable field. And if you take a look here, here's just a few of the various methods that the ActiveObject class overrides from the future interface that it inherits from. And you can see in all these cases that the cancel method, the isCanceled method, the get method, the isDone method, and so on, which we don't show, but which are there, they all simply forward to the mRunnable future to do whatever is being requested by the client, be that cancel, checking to see if cancellation has occurred already, and get the result, and so on and so forth. So this is how we're going to be able to connect together the world of the future task, which is going to run this computation in the background, with the set of methods exposed by the future interface inherited by the ActiveObject class. And we'll take a look at this in more detail. The next part of this lesson, which we're going to look at in just a moment, shows how the future task class can be combined with the Java future interface and the ActiveObject pattern to do all these cool things. And it's a really nice example of kind of stacking together various features that are part of older Java, the object-oriented part of Java, as well as modern Java, and then being able to create a nice, helpful, reusable abstraction like ActiveObject, and then apply it to something useful. So that's the end of the introduction to Java future task.